Hello everyone. So before starting my video, first and foremost I would like to thank the Department of Physics, Dr. C.P. Sir, Namchi Government College and the Sikkim University for providing me such a beautiful platform to make a video for the partial fulfillment of BSc Honours 6th Sem 2021. Hi, this is me Madhav Gurung, bearing roll number 18NS0011, and this video carries 25 marks instead of 25 marks practical examination. So now today in this video we are going to learn about the introduction, principle, construction, working and the limitations of a Betatron. Betatron. A Betatron is a type of cyclic particle accelerator. It is essentially a transformer, like you can see in the figure, okay, with a torus-shaped vacuum tube as its secondary coil. An alternating current in the primary coil accelerates electron in the vacuum around a circular path. The Betatron was the first machine capable of producing electron beams at energies higher than could be achieved with a simple electron gun. And the Betatron was developed in 1935 by Max Steinbeck in Germany. Okay, so it was basically developed by Max Steinberg in Germany in 1935, and it was like developed to accelerate electrons. But the concepts ultimately originates from Ralph Weider, whose development of an induction accelerator failed due to the lack of transverse focusing. Okay, and the idea was originally originated from the Ralph Weider, okay, whose development of an induction accelerator was failed due to the lack of transverse focusing. And subsequent development occurred in the United States through Donald Crest in 1940s as well. Now let us see the principle. Betatron works on the principle of electromagnetic induction. According to the electromagnetic induction principle, an alternating current in the primary coil of a transformer induces a similar current in secondary coil. The primary current produces a magnetic field which induces potential in the secondary winding. Like we can consider the secondary coil of transformer, okay, to be moving cloud of electrons in circular orbit due to magnetic field in donut-shaped chamber. And this principle was like the principle of mutual electromagnetic inductions was given by the Faraday. So basically it is the principle on which the Betatron works, okay. And now let us move to the constructions of a Betatron. A Betatron consists of electromagnetic pole pieces. This electromagnet works of high voltage AC input, okay. The donut chambers are arranged in the pole pieces like shown in figure. The figure is not visible yet, but I will show you all after a few minutes, okay. So first let me finish this. The electromagnet produces strong magnetic field at the center of donut vacuum chamber. So now here in the figure 9.5a you can see the pole pieces for the Betatron, okay, which is in donut shaped. You can see in the figure as well. And 9.5b is the figure for systematic of Betatron chamber. In the 9.5b you can see the orbits of electrons, X-rays, okay, and the electrons, and at the left hand side you can see connected to vacuum pump, and at the right hand side you can see electrons which are connected to electron gun. Now the electron revolves in circular orbit in the donut-shaped vacuum chamber. You can see that donut-shaped vacuum chamber in figure 9.5a. Okay, the magnetic flux phi associated with the orbit changes continuously with the change in time. Hence, as a consequence, the electrons gain energy by the process of magnetic induction. And if you remember, then we have discussed in the principle that Betatron works, or it is based in the principle of electromagnetic induction. And in my previous video we have learned about the cyclotrons, where I have also mentioned that the magnetic field always increases the radius of orbiting particle. But in the case of Betatron, the transverse magnetic field makes the electrons move in constant orbit, which means that the radius of the orbit is not changing, okay, it is remaining constant or same. The magnetic field provides the necessary centripetal force so that the electrons move in circular orbit. The magnetic lines of force should be convex outwardly for proper magnetic focusing. Okay, for proper magnetic focusing, the magnetic lines of force should be convex outwardly. The donut chamber is also coated with a silver layer from inside. Okay, there should be no accumulations of electrons, and moreover, the generation of eddy currents should be minimized by keeping the conductivity of layer to be very small. So eddy current has to be like checked, or it has to be minimized. Okay, its generation should be minimized. The eddy currents hinder the operating conditions of Betatron, as they tend to distort the magnetic condition, and for this reason the generations of eddy current has to be minimized. Okay, so now with this we are done with the constructions of a Betatron. Now we will look upon its working. Here you all can see in the screen, an electron gun is used to inject the electrons into vacuum chamber. You can see that electron gun in figure 9.5b also. Okay, the electron gun consists of a heating filament as electron emitter. The injections of electron is done when the magnetic field is rising during the first quarter of the AC cycle, as shown in the figure 9.6, which I will be showing to you few minutes later when I am done with this. Okay, and the electrons get accelerated during the rising magnetic field due to increasing potential within the donut. Even after increasing kinetic energy of electrons, the electrons orbit in the same orbit of radius r, unlike in the case of cyclotron where the radius of the orbit is continuously increasing, right? Then the magnetic field starts decreasing after passing through a maximum. So which means that the maximum magnetic field, after the maximum magnetic field, it will again start decreasing. Okay, then the electrons start accelerating. Then the electrons will get deaccelerated. Okay, and they will start deaccelerating as the directions of the electromagnetic force starts getting reversed. which I have already said like above, that the magnetic field will start decreasing when it reaches its maximum value. Okay, and after that it will again start decreasing, and as a result of which the electrons will start deaccelerating, okay, as the directions of EMF will also get reversed. So to avoid this effect, the electrons are removed at peak magnitude of magnetic field. Okay, so in order to avoid the deaccelerations of the electron, they are removed at peak magnitude of magnetic field. Okay, these ejected high energy electrons can strike target T to produce X-rays that emerged out of the apparatus. To remove electrons from the orbit, a current of large amplitude is sent through auxiliary coil that abruptly changes the magnetic field. The theory behind the working of Betatron can be demonstrated using Faraday's law. According to Faraday's law of electromagnetic induction, which we already know, the induced EMF due to changing current, or you can say magnetic flux, linked with a coil is given by the equation E is equal to d phi b by dt, okay, where phi b is the magnetic flux which is perpendicular to the plane of circuit. Now, during one revolution, the work done on an electron is given by the equation W is equal to Q d phi b upon dt, okay, where Q is the charge of electron. Now, the force acting on an electron during one revolution is given by the equation work done by distance traveled during one revolution, okay, and by simply substituting the value of work done from the above equations, we get force is equal to F is equal to Q d phi b upon dt by 2 pi r. Okay, so this 2 pi r is the distance traveled during one revolution by the electron, and since electrons are following the circular path, okay, circular orbit, so the distance is taken as the circumference of the circular orbit. Now we also know that when magnetic field is acting on the charged particle, the Lorentz force will be definitely there, okay, so which is given by vector F is equal to Q vector V cross B, and on simply using the vector rule, okay, cross product rule, we will get F is equal to QVV sin theta. Here the magnetic field is perpendicular to the velocity of electron, so the theta will be 90 degree, and just simply putting the value of theta 90 in sin theta, we will get sin 90, okay, and sin 90 will be 1, and the equation F is equal to QVV will be formed. This Lorentz force provides the required centripetal force, okay. This is the similar thing that we have also discussed in my previous video regarding the cyclotron, okay. The same thing was done there also. VQV is the Lorentz force, and the centripetal force is given by mv square by r. So on performing simple cross multiplications and calculations, we will get mv is equal to vqr and p is equal to bqr, where p is equal to mv. According to Newton's second law of motion, where p is the momentum, right? So according to the Newton's second law of motion, the rate of change of momentum is given by the equation F is equal to force is equal to change of momentum with respect to time, and just simply putting the value of the momentum we have got in our equations, we will get force is equal to d dt of bqr, and just simply taking qr outside, we can write the above equation as F is equal to qr dv by dt. Okay, so now from equation number 18 and 21, in equation number 18 we have got the value for like force is equal to q d phi b upon dt upon 2 pi r. Okay, in equation number 18 we have got the value for the force, which is equal to q d phi b upon dt upon 2 pi r. Okay, and the equation number 21 we have is F is equal to qr dv upon dt. So on simply substituting the value of equation number 18 in equation number 21, we will get qr dv upon dt, and in the right hand side we will get q d phi b upon dt upon 2 pi r. Okay, and this is the value of force we have substituted from the equation number 18. Okay, and simply rearranging the terms and doing the cross multiplications, we will get d phi v upon dt is equal to 2 pi r square dv upon dt. Now again solving and doing the simplification, we will get d phi v by dt is equal to, putting pi r square with the b, we will get d phi b upon dt is equal to twice d upon dt pi r square b as our equation number 22. Equation number 22 is known as flux condition. Okay, so the point is very much important, which we are going to learn now. This condition states that the flux phi v linked with a coil must change at a rate twice the rate if the magnetic field is uniform throughout the orbit in given time interval. Okay, I'm just expressing the equation number 22 in words. Okay, the same thing is there but in the expressions. Okay, so these are in the words, and this relation hold goods in the relativistic as well as non-relativistic regime. Okay, and equation number 22 we can also write as 2 d dt of pi r square v is equal to d dt of pi r square v naught, where v naught is the average magnetic field. Okay, and hence on doing simple simplifications or performing or solving these equations, we will get b naught is equal to 2b. So equation number 24 is known as Betatron condition. Okay, hence the magnetic field must be shaped such that the average magnetic field over the total space enclosed by orbit is equal to twice the magnetic field at orbit, um, which means that the magnetic field must be shaped in such a way that, okay, the average magnetic field over the total space enclosed by the orbit is equal to the twice of the magnetic field at orbit. Okay, the Betatron performance is also limited by some factors. For example, the accelerations of particles becomes very difficult after achieving the relativistic speeds. Secondly, electrons are negatively charged. After this acceleration, the electrons always radiate energy in the form of electromagnetic waves. Now, the kinetic energy of electron is also fixed when the energy lost by electrons in the form of electromagnetic radiation becomes equal to energy gained by electrons during their acceleration. then there is no further rise in the kinetic energy of electrons. The Betatron usually requires a source of 60 Hz. Okay, Betatron has very bulky electromagnet, and like in the United States, General Electric labs have produced 100 mega electron volt electrons magnet, approximately 130 tons, and the maximum magnetic field, which is equal to 0.4 Tesla. This Betatron was used during World War II, which was a renowned war, as an intense source of penetrating X-rays. Now, the limitations. This type of particle with maximum energy can impart is limited by the strength of the magnetic field due to the saturations of iron and by practical size of the magnet core. It is actually a transformer which acts as the secondary coil of the transformer. This accelerates the electrons in the vacuum tube around a circular path. It works under constant electric field and variable magnetic field. So, this much for today, and thank you so much for watching.